Hey there, welcome to this explainer, where we're going to prove once and for all that time-speed-distance problems are actually just a game of logical shortcuts, not tedious algebra. If you've ever found yourself bogged down by endless equations while the clock is just mercilessly ticking away on an aptitude exam, and you're staring at a blank page feeling that familiar panic set in, well, you are exactly in the right place. We're going to completely flip the way you look at these problems.
Here is our quick agenda for today's masterclass. We'll be hitting the core TSD trinity, unlocking some essential speed and time hacks, mastering specific environments like trains, boats, and races, completely sidestepping common exam traps, and then wrapping up with a 7-day blueprint for total mastery.
All right, let's jump right into part 1, the core TSD trinity, or the only 3 formulas you actually must memorize.
Now, these 3 formulas are incredibly simple, right? Speed equals distance over time, distance equals speed times time, and time equals distance over speed. But here's the absolute secret. It's all about proportionality. Think about it like this. If you drive twice as fast over the exact same distance, it takes you exactly half the time. Grasping that inversely proportional relationship, that is the real trick. That's what allows you to start predicting the answers before you even pick up a pencil.
Okay, moving right along to part 2, essential speed and time hacks. This is where we move way beyond basic arithmetic.
Picture this scenario. You're driving to a destination at 40 kilometers per hour and then returning along the exact same route at 60 kilometers per hour. So, what's your average speed? Most test takers see this and immediately fall into a very specific, perfectly laid mathematical trap. Your brain just wants to take the easy way out, but you have got to resist that urge.
And here's exactly why you never use the arithmetic mean for equal distances. The trap is so tempting. Just add 40 and 60, divide by 2, and guess 50, right? No way. That's wrong. Because you actually spent more time driving at the slower speed, the true average is skewed lower. Enter the harmonic mean. You multiply 2 times the first speed times the second speed, and then divide by their sum. So 2 times 40 times 60 is 4,800. Divide that by 100, and boom, you get exactly 48 kilometers per hour. Seriously, lock this formula into your brain.
Now, here's another incredibly powerful tool, the LCM method. I like to call this the great escape from constant time. Instead of setting up complex variables with x's and dealing with horrible messy fractions, you just assume the total distance is the least common multiple of the times given. So if one trip takes 3 hours and another takes 4, just pretend the track is exactly 12 miles long. Suddenly your speeds become these beautiful, clean, whole numbers and the algebra literally vanishes.
All right, let's talk unit conversions, because doing long division by 3.6 or multiplying by 5/18 in the middle of a high-pressure test, yeah, that is just wasted time. Instead, you need to memorize this single base ratio. 18 kilometers per hour is exactly equal to 5 meters per second. This right here is your new mathematical anchor.
See how nicely this builds? Once you have that anchor, everything scales flawlessly. If a problem doubles the speed from 18 to 36 kilometers per hour, you don't calculate a single thing. You literally just double the meters per second from 5 to 10. Done.
Let's take it even further. Snap to 72 kilometers per hour? Instantly you know it's 20 meters per second. What about 54 kilometers per hour? Well, that's just 3 times 18, so it's obviously 15 meters per second. This kind of mental scaling is a ridiculously simple trick, but it yields massive dividends on the clock.
Which brings us to part 3, trains, boats, and races. Let's master the environment.
Exams absolutely love wrapping simple math in these little environmental boss battles, especially trains. With trains, physical length matters. Crossing a stationary pole, your total distance is just the train's length. Crossing a platform, your distance is the train plus the platform. But the real magic is relative speed. If 2 trains are charging towards each other, you add their speeds to see how fast that gap closes. If they're moving in the same direction, you find the difference. Mastering this basic logic instantly demystifies train problems.
Boats and streams are another classic variation where the environment modifies your speed. Downstream, the current pushes you along. Upstream, you're fighting it. But here is the ultimate hack. If an exam asks for the boat speed in still water, literally just take the average of the downstream and upstream speeds. Go downstream at 20 and upstream at 10, your still water speed is exactly 15. No complex formulas required whatsoever.
Finally, we've got races. These scenarios are basically designed to induce panic. Let's say in a 100-meter race, runner A beats runner B by 20 meters. We already know A's speed is 10 meters per second, so how in the world do we find B's speed without getting completely lost in algebraic variables?
Well, most people go the slow way, right? Writing out a whole paragraph of messy equations. But if you remember our secret weapon, that distances are proportional to speeds in a fixed amount of time, you can solve this in 2 seconds of mental math. If A runs 100 meters at 10 meters per second, it takes A exactly 10 seconds to finish. Since A beats B by 20 meters, that means in those exact same 10 seconds, B only managed to run 80 meters. Distance over time, 80 divided by 10, is 8 meters per second. Pure logic, zero algebra.
Let's hit part 4, avoiding common TSD traps. We are not losing easy points today.
Now that you have this whole arsenal, you need to navigate the minefield. The test makers know exactly what assumptions you're going to make, so keep a really sharp eye out for these false assumptions. Mistakenly adding relative speeds when objects are moving in the same direction is a huge one. You must subtract them. Never use the arithmetic mean for equal distances. Rely on that harmonic mean we talked about. Do not forget the platform's length in train problems. And for circular tracks, just remember the first meeting point is rarely the starting point. Treat all of these traps like giant red flags.
Finally, part 5, your 7-day mastery plan. We're going from novice to expert.
Look, learning these shortcuts is one thing, but making them a reflex. That takes a little bit of structured practice. So here's your highly actionable blueprint. Days 1 and 2 focus exclusively on proportional hacks and the harmonic mean, solving 20 targeted problems. Days 3 and 4 dedicate yourself entirely to trains, boats, and races. Days 5 and 6 dial in the LCM method and circular tracks. If you stick to this segmented schedule, by day 7's mock exam, I guarantee you'll be slicing through these problems in under 45 seconds each.
Let's wrap up this explainer with one core truth. Time, speed, distance is not about complex formulas. It is about choosing the correct relative speed and the correct distance. These 3 quantities are inextricably linked. Fix 2, and the third just reveals itself. The tactical guide we've just gone through gives you the exact shortcuts to decide which 2 to fix first. So, my final question to you is, are you ready to stop calculating and start outsmarting the test?